problem, most likely a limit problem is going to involve the use of L'Hopital's rule. And I'll just mention this really quick. Those of you that had Miss Hires for BC first and second trimester, she did not cover L'Hopital's rule, yet she was saving it for third trimester. So some of you may have never seen this before. Please pay special attention to how we approach it and the work we need to show. So what we would normally do with the limit is try direct substitution. We're going to plug 0 in and see if that works. But you will notice you'll get a 0 over 0. So what do I have to show for this? And if this was a free response question. Now, multiple choice, don't show any work, right? Do as little as you need to. But if this was a free response question, you would have to show exactly what I'm showing here. You'd have to say, well, I'm going to take the limit of the top function. So you write it out, and then you do direct substitution, and you see you get 0. And then you have to do the limit of the bottom function. And notice how I'm writing this whole equation, or this whole function out. You have to show that, because that's the rules or the stipulations of L'Hopital's rule. You have to show the limit of the top and the limit of the bottom separately. And then you don't have to show this little step here, but know that e to the 0 is really 1. So I really end up with 1 minus 1, or 0 over 0. What that does is that gives us the indeterminate form. We don't like that, right? When you have 0 over 0 or infinity over infinity, 0 over infinity, all of those are indeterminate forms, which means we have to take another approach to solving. And you have to show this work ahead of time if it's a free response question. So then L'Hopital's rule is take the derivative of the top and the derivative of the bottom and evaluate it at the same limit. So the derivative of the top is 8x. The derivative of the bottom involves a chain rule. It's e to the 4x, but then I would have to do the chain rule. The derivative of the top is going to bring another 4 out front. And then I've got minus 4. Now we're at the same spot. You're going to reapproach this the same way we just did. And notice, if you plug in 0 to the top, you're going to get 0. If you plug in 0 to the bottom, you're going to get e to the 0, which is 1 times 4. You get 4 minus 4. You're going to get another 0 over 0. If it's free response, you have to show this work. Okay, don't be lazy, because this is something that I think everybody should be very comfortable with. Now, you can't just plug in 0 over 0. You can't plug in the fraction. And it's because of the way L'Hopital's rule is written that says you have to take the limit of the top and the limit of the bottom and evaluate each one of them at, in this case, x equals 0. So you don't have to show any extra work here. You can do this in your head. You know 4 minus 4 is 0. But notice we get that indeterminate form again. Now, usually, L'Hopital's rule is applied once or twice. It could be applied as many times as possible, or sometimes you keep applying it and it's not going to work. There's a lot of different scenarios, but in this case, if we do this L'Hopital's rule again one more time, look at what the top does. The derivative of the top is 8. That will not turn into 0. So I know for sure I'll be able to make a conclusion after this step. But then I have another chain rule. So the derivative of e to the 4th is e to the 4x times another 4. So that's going to give me a 16. And then the derivative of the minus 4 goes away. Since I am confident that will not use L'Hopital's rule anymore. Now you can just do direct substitution, and you don't have to show those steps. I'm just going to plug in 0. And remember, e to the 0 is really 1, so 16 times 1 is 16. All that work got me to the answer of B. My goal is to sprinkle L'Hopital's rule into maybe next week's at some point again, just to see if you guys are ready for it. But those of you who had mishires for BC, this is a new concept, and it's pretty easy as long as you follow the rules. Show the limit of the top goes to 0, show the limit of the bottom goes to 0, and that's our sign for an indeterminate form where we have to take the derivative of the top and bottom and now evaluate the limit at the same. Okay, and then you keep doing this, and you do it as many times as you need to until you get your answer. All right, so hopefully that was a good refresher. We got one more warm-up here, and of course, kind of small. This one's kind of tough. Our goal today is to analyze tables, and this is a multiple choice question that involves a table. I'm going to give you about a minute here with tables. When we have a table that's given, you can only make conclusions based off of the points that are given. What you can't do is you can't say, okay, well, if this is at -2 and this is at 0, -1 must be at +2. You can't make assumptions for that. We don't know what's happening between the points on any of this table. So don't make assumptions. Only use the facts of the table that are given. So let y be a polynomial function where the derivative of select values is given in the table above. So here's the derivatives. It says, which of the following must be true from the interval from -2 to 6? Well, the graph is concave up. If the graph is concave up, that means that the second derivative is positive. Now, we don't have the second derivative, but if I did the slope between these points, the slope should always be positive. And if that's true, then the option will be A. But look at the first one. If I do the slope between these 2 points, if I just did 1 minus 3 over 0 minus -2, right there, see how that's a negative? That would mean that between this point and average rate of change would be negative. So the second derivative would not be positive. So right away that reduces A. I'm going to skip around here. F has no critical points. Okay, well, remember, we can't make assumptions either for or against this. Notice how my derivative, if I have a critical point, the derivative would have to equal 0. Well, the derivative doesn't equal 0, but it could. So we don't know either way, so we can't use that as a conclusion. Same thing here. F has at least 2 relative extremas. If there's a relative extrema, then we would probably have to have a 0 slope, which we might. But I don't know if there's more than that, because I don't know if I'm at 3 here, and then all of a sudden I drop way down to -20, and then I come back up. I cannot tell extremas just from a given table, unless there's a 0 in here. So it really leads me to look at B and C. Now, here it says F is increasing. Well, if F is increasing, that means that the derivative is always greater than 0. We don't know what's happening between these points, right? And these points are the derivative. I don't know if I go down to negative or not. So I can't always be increasing. Also, notice we'll stop there. So, process of elimination, the option is B, for sure. Here's my explanation when I did this. Why is it B? And again, this is something you would not have to write down. But what do we know? F prime of x changes from decreasing to increasing somewhere on the interval from -2 to 3. You see how from here to here we have to go from increasing to decreasing. So I go down from 3 to 1. So we're going down, and then I go back up. So I have to change at least once on that interval. Which means if I have a change in the first derivative, that's a point of inflection. Right? That's where your second derivative would equal to 0 at some point. And then the same logic is applied here. We go from increasing to decreasing somewhere on 3 to 6. So look at from 3 to 6, I go from 4 to 7. So I increase, and then I decrease to 5. So my rate of change is changing, which means I have a change in point of inflection. So therefore, there's at least one of these intervals where f of x has at least 2 points of inflection. That's where the second derivative will be equal to 0. The big takeaway from this, this is a difficult problem. Just remember you cannot make assumptions about anything else in this table. All right. Our job today, and since we're talking about tables, is to also talk about Riemann sums. And we've done, I think, 2 of these already. But I just want to make a quick reference. Remember when we do Riemann sums, what do you have to do? You have to divide the interval up into subintervals. And they're going to probably tell you exactly how many intervals you need, right? 3 intervals, 4 intervals. And then you could use left-hand, right-hand, midpoint to find the height of the rectangles, calculate the areas of each rectangle, and then add them all together. When you're doing a left-right or any of these Riemann sums, you need to start with the integral from your starting point to your ending point of, maybe they give you a function, right? So you need to show that integral sign, because that's what this is estimating. It's approximating the sum of the area. Now, really quick, when I say left, that means if I have my boxes, we're starting on the left side of the rectangle. Here, here, and here. If I say right, then you're doing the rectangles, but now you're going on the right side of each of those rectangles. If it's the midpoint, notice that right in the middle of that rectangle, you're using the point in between the 2 bounds. Now, trapezoid is the one thing with a trapezoid. Let's see if I can fit this in. I'll put it down here. You have 2 options for trapezoid. If you know the left and the right, the average of the left and the right will automatically give you the trapezoid. I haven't seen that come up a lot, but it could. They could say, here's the left Riemann sum, here's the right Riemann sum, find the trapezoidal. And you just find the average of those 2. But if you don't, then you have to do the idea of a trapezoid. And remember what that is. The height here is base 1. The height here will be base 2. And then the distance between them is considered the width or the height of your overall trapezoid. And you do have to have this formula memorized. They are not going to give this to you. But remember the area formula for a trapezoid. 1/2 base 1 plus base 2 times the height. And the base 1 and base 2 are just those vertical distances up to the points on the curve. So, we've done that. We haven't done it in a while, but hopefully you remember that. Now, most of the time, they're not going to give you a graph. And you don't need a graph. Right? You have a table. So just remember what this would look like if I did this on the table. If I wanted to do the left ram, and I had 4 subintervals, I usually do this on my table. You can see I got 4 rectangles. If I wanted to calculate the left ram, I'm going to use the left endpoint, which is 0, and the width, the distance from here to here, is from 0 to 12. So its area of that first trapezoid would be 0 times 12 plus the next one would be the width from 12 to 20, so that's 8. And then we're using the left endpoint, which is 200. And so on. I think you guys can get it from there. I'm not going to do all of this. But what if I shifted and then I said, you know what? No, we want to do the right endpoint. You still have the same amount of intervals. The width doesn't change, but it's the endpoint. So now to find the area of this rectangle, I would take 12 times this height, which is 200. So 200 times 12 plus the next one would be 8 plus 240, or 8 times 240. And then you would keep going on. Now this is not a good one. This example is not good for midpoint. If I wanted to do midpoint on this, I would have to go from here to here, and then 12 would be the midpoint. And then I would have to go from here to here, because otherwise I wouldn't know what the midpoint output would be. So if I wanted to do the midpoint with the 2 green ones, I would take its width, so 0 to 20, I would do 20 times the midpoint height. What's the midpoint height of this first rectangle? 200. Okay. And then there's only one other rectangle. The width from 20 to 40 is 20. And then the height at this midpoint would be negative 220. And that's as far as we could go with that one. So notice we don't need a graph, but we kind of draw one anyway. All right. And then how would I do a trapezoid with this one? This is how I do it. It's not super accurate, but I just think of, here's a trapezoid. What is base 1? Well, base 1 is the output. Base 2 is the output. I'm not going to get super detailed with this, but the area of the first trapezoid is 1/2 base 1 plus base 2 times the height. So it would be 0 plus 200. And then the height isn't how tall it is, it's the width of the interval. And then you would just keep going. The one thing you do have to be aware of is if I go to my next trapezoid, now it's this one becomes base 1, and this one becomes base 2, and the height is the difference between that. So I would do 200 plus 240 times the height of 8. And then you would keep going for however many times. So I just hope that refreshes your memory a little bit. I'm like 99% confident you'll see one of these in a free response question. And speaking of, I'd like you guys to try this. We're going to go about 15 minutes on it, and then we'll go over it together. And this one is calculator allowed. All right, so I have the answers on the next page, but I want to just kind of go through a couple of things here. Use the left Riemann sum. What I would do here is draw my boxes, and the left Riemann sum is using these endpoints. And then you have your widths there. So let's look at how part A would be written out. One of the things you should do is they ask you to approximate the volume. Well, you should write this part right here. Volume is the integral from the start to the finish, so from 0 to 10, of the function a of h, dh. So you should write that, and then here is, I don't think I would write this step, I would write this step right here. That's the area of the first box, second box, third box. Now remember, you don't get any extra points for simplifying. So you could stop right here, but you do have to include the units, because they did say identify the appropriate units. And if we're adding up square area, that's volume, which is cubic feet. Your final answer, if you did get to it, is 176.3 cubic feet. Rounding is important. If you didn't round correctly and you didn't get that answer, then you should, actually I'm going to check. Yeah, I got exactly that answer too. You got to be very careful just with how that's set up. Now, part B is interesting. It says, is it an over or an underestimation? Well, let me show you what parts hint at this. So does the approximation part A give us an over or an underestimation for the volume in the tank? Explain your reason. Well, they tell us in the directions that the tank has a height of 10 feet. The area of the horizontal cross-section of the tank height h feet is given by the function a of t. A of t is measured in square feet. The function of a is continuous and decreases as h increases. So let's look at that. As my height in feet grows, my function decreases. Well, that's the key part right there. And they actually, if you wrote this sentence down right here that I just highlighted, that's your explanation. But let's show why that's the case. If I was to graph this, okay, which I'm not really going to, but I have a spot up here at 50.3, and then I go down to 14, 6, and 2, something like that. But you can see that that function is decreasing as the height increases. Well, if this was a continuous function, which is not, but if it was, well, actually, take it back. It is. And it's always decreasing, so it's going to look something like this. What are we doing? We're doing the left Riemann sums. So if you drew those left rectangles in there, you see that overestimation. The answer we found in part A is over because the function is continuous and decreasing. So therefore, we have an overestimation. How do we write that? This was the visual component, just to prove that it's that way, but here's their explanation. It was given that if h increases from 0 to 10, then a of h decreases on the interval. Hence, the left Riemann sum in part A is an overestimation. That's all you have to explain. Because we know that if a function is decreasing overall, the left Riemann sums will always be an overestimation. I'm a visual learner, so I drew that little graph just to show that. The graph is not an explanation. That's just for you to make sense of the problem. Okay? All right, part C. I'm going to jump back here quick. So part C says the area in square feet of the horizontal cross-section at height h of feet is modeled by the function of f. So this is the area function. Now it's where these points probably came from, but this is what we would use. Based on this model, find the volume. So remember what area is. If I accumulate area, that gives me volume. When I say the word accumulate, what pops into your head? The integral, right? And where's the integral? From 0 to 10. Right? So I'm going to take this function f, and since this is done in my calculator, all I'm going to do is say the volume from 0 to 10 of the equation, which they gave us the equation, plug it into your calculator, there's your answer. They would accept it as well up to 3 decimals. If you rounded less than 3 decimals, you wouldn't get the point for it, which is kind of sad, but you have to be accurate, and that's what they're looking for. So this is a straight show. Now you should, by the way, even though you do this all on your calculator, you need to show this setup. They need to see what you did in your calculator. And it's a really quick thing. You don't even have to write the equation. You can call it f of h because they gave us the function f of h. All right, part D I think is kind of challenging because of how wordy it is. When you look at it separately, it's not that bad, but man, is there a lot of words to it. So let's dissect that just a little bit here. Water is pumped into the tank. When the height of the water is at 5 feet, the height is increasing at a rate. Now that's interesting right there. The height is increasing. I'm thinking right away, if they tell me it's a rate and it's height, I'm thinking that dHdt, so the change in the height compared to the time, is 0.26 feet per minute. Okay, so that's what I get away from that piece. And then it says, using the model from part C, so using this function, find the rate at which the volume of water is changing. Well, wait a minute. Find a rate of volume. So I have to find dV dt, which next week we're going to get into looking at these rates of change or related rates, but this is an early example of one. When the height is 5. So what I need to do is I need to set this up. Well, what is it? Remember, this equation is area. They're asking me to find the rate of the volume, so I need some equation that represents volume. And what is volume? It's the accumulation of the area function from 0 to some h value. And I believe this should be dHdt. So that's, you had to take away from this term right here, find the rate at which the volume of the water is changing. From that blue piece, you needed to come up with that equation, which is challenging, right? Now, if I have the equation for volume, how does it turn into a rate? You take the derivative. So, I would take the derivative with respect to time of all of this, and that would turn into dV dt. That's how the volume is changing. What happens when I take the derivative of an integral? Cancels out. And what's left over is f of, now it can be t, because t with prime, it could be h, it doesn't matter, but if I take the derivative and plug this in, remember how we always did the chain rule? I have to multiply by the derivative of what's going in there, so I have to times by the rate that the height is changing, which we know. Now, after all of this, notice how I didn't do anything with this 5 feet. That's the end spot. So find the rate at which the volume of the water is changing with respect to time when the height is 5. The very last thing I would do is evaluate this when the height is 5. Which means I'm going to plug 5 in for h. I already know that this height is changing at 0.26. And then the only question is, where do I find f of 5? Well, notice you have a calculator. You're going to plug 5 in for h, and just figure that out in your calculator, multiply it by 0.26, and then I'll just show you. This is their explanation, which is the same thing, except I didn't show a ton of work, and I should get 1.694 rounded to 3 decimals. And then this is volume. If they ask for the units, remember the volume is changing, so it's the cubic feet per minute. Because, so it's the rate that the volume is changing per time. So time is just always whatever unit it is. And then volume has cubic feet. So it's the units of volume over time. All right, like we said, that one kind of tricky, right? That might be one where I would say, this skip part D, and if you have time, come back to it later on. But don't spend a lot of time on something you're not going to figure out until you've tried all the other problems for that section. So those are test-taking strategies that you definitely want to keep in mind. I'm not going to read through all this. I'll just post this. These are, when you're dealing with a table, there's some do's and some don'ts. What should you do? What shouldn't you do? I've talked about pretty much all of them today. The only thing I guess is, and this is what should you be able to do. Remember, if we ask you to find average rate of change, that's just the slope, right? If you're given a table and you're asked to find the average rate of change, you're just asked to find the slope and use points close to that value. Don't get that confused, though, with average value. Know the difference between average rate of change, which is regular slope, and average value. Remember, just quick about average value, that's the integral. If I ask you to find the average value from A to B of t dt, the average value is when you just do the upper bound minus the lower bound up. So you really have to pay attention to how the words are written. Okay. So anyways, this will be on Schoology. You can go through and read it if you'd like. And then the one thing, I think I mentioned this. So when you're doing your practice exams, there are a couple of questions that it said skip, handwritten. That was for last year when we didn't teach Unit 8. You should do those ones that say skip. So do all the problems on the practice test, and then remember the answers are here. All right, so we're done a little early. If you guys have any questions on Zoom, let me know. I'll read the chat. If you're good, you can go. If you would like to come back at 12:55, we're going to be answering questions during our work session. Have a great one. Adios.